And good afternoon, everyone. Welcome to another Gretel workshop. My name is Mason Egger, and I will be your host today. It's good to see everyone. It's been a minute since we've done one of these. Today, we will be doing a workshop on generating synthetic data from a relational database. This is a really fun topic. It's one I really enjoy talking about. Because not only are we going to talk today about generating synthetic data from a relational database, we're actually going to talk about a couple of other tools that Gretel has that I don't really talk about that much that I actually think are really cool, which is our classify, which we're going to talk about that like very briefly, and our transform tool. And this is going to really help us kind of shape what we're doing with privacy around this stuff. So as you may have known, as we've talked before about synthetic data, you can use synthetic data for privacy protection. So you could say take a database and then go from there and generate a set of synthetic data, and you have some decent privacy, not concerns. That's not the word for it. What's the word for it? You feel good about it. You feel good that that data is not necessarily, going to be having PII in it. It's not going to leak. I cannot think of that word right now. It's pretty funny. So that's pretty awesome. But from there, where we're going to go from there is we're going to talk about, well, what happens when we pair the synthesis, the Gretel synthesize, with another one of Gretel's tools, which is transform, which is a tool that takes a data set and then transforms the PII. So before you're even doing the synthesizing, you're detecting and transforming the PII, and this adds for maximum amount of privacy protections. So I'm going to give it a little bit of time for everyone to kind of jump in. Here we've got a couple people I can see viewing. I can always see the number of people that are viewing. So if you're in here, come say hi. Come say hi in the chat. If you have any questions during this time today, feel free to drop any questions in the chat that you want. And we're going to give it about another minute, and then we're going to go ahead and get started talking about synthesizing data from a relational database. Tea, the drink of Mason whenever he does live streams. I'm from the South. I love iced tea, but I don't drink sweet tea. It's not good for me. Tea was the compromise. I get to have caffeine, but I can't have sugar, so we do tea. Anywho, those are the things. These are the thoughts that go through Mason's head. Okay, well, let's go ahead and get started. Thank you for tuning in. So let's talk about generating synthetic data from relational databases. So, yeah, let's go ahead and remove that banner real quick. So what we're really going to talk about today, and I'm going to put this, I'll copy and paste this into the comments. I'll put this in the comments so anyone can view it, and I'll add it in a couple more times as we go through. We're going to be talking about this really good blog post that we have from my colleague at Gretel, Amy, talking about synthetic transforms on relational databases. So this blog post is kind of a follow-on from an earlier blog post that you might find on our blog, which talks about doing relational database synthetics on multi-table relational databases, which is what we're going to talk about today, is multi-table, like synthesizing multi-table relational databases. But this blog kind of takes it one step further. And where this blog goes further than the original blog is the original blog just talked about synthesizing. So while synthesizing a data set can give you some pretty decent privacy, oh my goodness, I cannot think of this word. You can feel good about it. Does not give you privacy concerns. It gives you, I guess it gives you some stability of mind, some that you're happy, that it is, my goodness, that you are like satisfied with the fact that it is relatively private. PII could still technically come out of that. It's secure, but it's not the most secure we could do. What we can do with that is we can take the Gretel transform and then transform our data from just basically removing the PII or separating the PII out, basically subbing it out and then synthesizing it. So if we say it's kind of like a multi-step process. If you think about, if we have a potato and we cut up the potato is cut up. That's one step. But if we cut it up and then we like fry it, that's two steps. And now it's even harder to get back into the original form than the potato, kind of like the hashing, metaphor that people use. So what we're going to do is we're going to talk about taking a data set, transforming it. So taking the PII and basically replacing it, transforming it into a basically anonymized version. And then we're going to take that anonymized version and then we're going to create synthetic data from that. And from there, we're going to have some of the highest privacy protections we can have with synthetic data. So that's what this blog post talks about. So there's 2 different notebooks that we're going to go through today. I'm going to be able to perform one of them live, the synthetics notebook and training on the relational data set. We're going to look at some previous runs that I've already done because it takes a relatively long time to train these notebooks, to train these machine learning models. And unless I, maybe bring up a video game and we all watch Mason play a video game for the next 3 hours, or it's not 3 hours, it took me about 30 to 45 minutes yesterday. We don't have time for that today in stream to kind of demo that live. So we're going to talk about it. We're going to look at the code, and then we're going to look at some past runs, and you're going to see how it works. So the first thing that's first, let's talk about the database that we're going to be synthesizing. So the database that we have is a mock e-commerce database that kind of shows a whole relationship between ordering items, inventory items, events, users, distribution centers, and products. So someone orders an item through an event. So basically, like, what IP address, where is it going to? And they take the order item. That order item goes and is basically linked to an inventory item. Which user, ordered the item? What product from the inventory item does it come out of? From which distribution center? And all that. So as you can see, this database is relatively linked together. There's a lot of relationships between them, and we're going to be able to generate synthetic data and actually maintain these relationships, which is going to be really fun to do. So let's go ahead and look at the notebook. So this is the Transforms notebook. So as you can see from this blog post has these 2 notebooks in it. So they're relatively straightforward to find. You can also find them, I believe, in the Gradle blueprints. Where is this one at? Oh, no, this is at the multi-table repository. So we should be good with that. Huh. Apparently things are blurry on YouTube today. That's weird. Don't know how to solve that. That's not really something I control on my side. If you're viewing it blurry on here, maybe try on LinkedIn. We're having some mild technical difficulties. Give me 1 second to attempt to view and see what's going on. No, it looks fine on my end. Okay. So one of the messages that came through said it was looking blurry, but it looks fine on my end, so it might just be their internet connection. So let's go ahead and go forward from here. So we have this database where we're going to do an RDB transform. So as you can see here, we already have our e-commerce database. We have this is the image, the same image that we talked about. And what we're going to do is we're going to go ahead and get started. And there's a library that Gradle has created called multi-table. So multi-table is currently a GitHub repository with a Python library in it. That it allows us to do this kind of multi-table synthesis. Now, where we're going from here is like in a couple weeks or so, there's actually like a newer version of this library that we're going to be putting out. So this is still useful and very highly configurable. But if you've played around with our trainer API or our trainer library at all, we're going to have a trainer version of this, which is going to be a lot easier and a lot cooler to work with. But for now, we're going to work with this multi-table library. Okay, we're connecting up here. And we're basically just going to clone this repository and do a pip install and install this library that we need. Doop, 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 doop. There it goes. Make sure that's the only thing we have to install that. Do I have anything else I need to install? No, we're good. So we've installed that. And now we can install this and get our Gradle API key. So as always, we're using our Gradle API key. Whenever you log into the Gradle dashboard, it's usually the first thing you see here. So we can come back to this library, to our notebook, and enter it in. And now we have access to it. So from here, we're going to go ahead and download this ecom-db. So this is an SQLite database. And that's what we're going to use today for the ease of not having to work with a managed database and a cloud provider. We're going to use SQLite today just to make life a little bit easier. If you want to see this talk and my intro to synthetic data talk that's being done, where I actually do this with Postgres, I did this in another talk that's going to be released at DigitalOcean's Deploy conference in mid-November. So I can personally attest that this create engine, which comes directly from SQL Alchemy, that all of this code works with Postgres and the other relational databases besides SQLite. And if you want to see that, check out that conference. It's coming up in November. But we're going to go ahead and run this. And what it basically does is we're going to download this database from Looks like it's stored in S3. And then we're going to create this engine for it. And then we have a method in here called crawlDB, which basically is going to crawl the entire database and build out CSVs of all of the tables and then all of the relationships and all of that. So that way we can feed it into Gretl, and Gretl will know that, hey, these were the relationships that we had. So a really cool thing that we have here is, alternatively, you don't have to use the crawlDB method. Maybe you want to remove a couple of relationships. Maybe you want to add, like, we really can't add any, but maybe you're having some trouble with this. I don't know why you would, but maybe you want to do it manually. And there's this down here, which is basically like, here is the base path for this S3 bucket. And what it is there's basically all these different CSVs of the database. So you can create your table files and basically say what table files they are. Actually, let's just open this, because this might actually be, if we can open this, it might, make a little bit more sense as to where that's not what we're looking for. Okay, so that's actually not, okay, so that is, I can't just go into view mode on that on S3. That's my bad. But basically, it looks like it will contain the database. And then we have these CSV files. Might have been a zip. Was it a zip file? I don't want to open it up again. And so these will be basically what our tables will do, which is what this crawl database is going to do. So actually, let's just, just take a look at it. This might be a little bit much for this, but yes. So as we can see here, it basically creates tables for all of these. That's a lot. So it has the table data, and it basically creates inside of here, inside the distribution, like the raw data for the tables, like we would do. And then there's a couple of other, like, it tells you where these CSV files are, what relationships there are. So basically everything that is inside of this RDB config that you can also manually do will show up in here. So the crawlDB thing already does it for you, but if we want to kind of look deeper into it, we can look into it here. So you see we have our table files. We specify what the primary key is for each table, just so we know. Currently, of the limitations of this synthesis is that your primary keys need to be IDs. So I think that says it up here. You might say it in the primary and foreign keys in your database must be IDs, and the keys cannot be composite keys. So these are already IDs, so this kind of looks like as it should. And then we basically say these are the relationships. Users have relationships to order items and events via the user ID. Inventory items and order items are related by this. So if we go back and we look at our thing here, we can kind of see these relationships. So order items, inventory ID to ID, we kind of saw that here, right here. And then with users, order items, and events, we can kind of see that user ID to ID and user ID for order items and events to ID, that these are the relationships. So this is how you would specify your relationships inside of this basically giant configuration dictionary that we have with Python. And then we basically gather the table data, but we're not going to actually run this block. This is an alternative to the crawlDB. The crawlDB already did what we needed it to do. So what we're going to do now is let's just take a look at our data. So we're just going to take two random tables, two IDs, and we're going to join them together, do an inner join on them, and see, like, hey, what do we have? So the number of records inside of this right now is 7,882. The number of records in the user table is 2,197. There's 7,882 records in the joined data. So it's the same size as the order. And then we can just kind of see, like, ID, order ID, user ID. It's not, the most interesting of data. It's got, the first name and last name of this person. I guess this latitude and longitude, I guess, is maybe the shipping address. That's interesting. That's how they would store it. But yeah, that's just how this database happened to work. Where did the traffic come from? Traffic came from source. So we're gonna be able to synthesize all of this. But where we're starting with this is we're going to transform it. So what we're going to do is we're going to create a very similar data structure of this database of this, but the data is going to be de-anonymized. So this is not technically real data right now. This is our sample data, but we could pretend that this is PII right here. So Bobby Fleming, their email. We really don't want this kind of data, anybody and everybody, to be able to see. So we're going to transform it so that way, now we have anonymized data that we can give people access to. So the next thing we're going to do is we're going to define our transform policies. So there are some default policies that we have defined. So what it says here is define one policy per table, which transforms any PII or sensitive information that could be used to re-identify the user. You don't need to include a transform for any of the primary foreign key combinations. We'll be handling those separately in order to maintain their integrity, so you don't need to worry about those. If a table contains a primary key that does not match to a foreign key, the field should be included in the transforms. Note the table's inventory items, products, and distribution center contain only public information, so there'll be no transformation. So again, this is us analyzing our data. This is, these won't have any PII in them because this is all public information, so we don't need to transform them. This is kind of something that one of the things that I talk about whenever I talk about synthetic data is, yes, you can use it to anonymize stuff. You can use it to synthesize a whole bunch of stuff. But the onus of validating your data and knowing what needs to be done still lies on you. So this is actually a really smart decision right here to don't waste any cycles on them using these models on database fields that we know that have only public information that can't possibly have PII in them. So this is a really good idea to do here. So you have to understand your data. If you don't know your data, safer than sorry. Go ahead and transform it. But in reality, if it's public, you don't need to worry about it. So the policy details, and I know I saw some documentation on this earlier. Here we go. So transform configurations. This is a little bit more like defined inside of our documentation, which I'll add to this notebook to make sure that you can directly link out to it. So there's different policies for how we want to anonymize the data. And we're going to go through and see what these policies look like. But there's different conditions, with the transforms, like what trying to transform. Do we want to fake it? Do we want to hash it? Is that how we want to do it? So these are relatively straightforward ways of doing stuff. So we can drop the record from the field, we can redact it, we can do a number shift. So there's different ways we can choose to handle this data depending on what you need it for. So let's go back to this repository or to this notebook right here, and we're going to run this real quick and just get it. So we're basically taking the policy directory and prepending it. So I guess we have these user policies inside of here right now. I guess we're going to save that, and we're just going to see what that is. It just says download with no kilobytes. Welcome to the magic of S3. I'll have to deal with that later. I was hoping that I was going to be able to open it. But basically, we're going to set our policies on a per table basis, and then we're going to say these are the YAML files we want to use. I had the configuration right here, so we would define these like so. So something like this. So what we're going to do is we're going to take this and then we're going to run it. And we're basically going to open up them. So I guess what's happening is that file, we have all those stored in there. I have so many different tabs open because there's different things I want to show you. Okay, Mason. Yeah, so we have these are stored in this S3 bucket. So when we do the adding them, when we concatenate the path together, we're able to get them. But here's the actual the policy that we have for users. Okay, so we're just going to kind of look at the users one. So we're going to say transform the data source, use the one. Using NLP, we're not going to do. If I remember correctly, this makes it take a lot longer, but it uses natural language processing to try to detect stuff that is a little bit more difficult. Like if you have a regex expression here or something, this is really useful for that. So we're going to do a user transform where we're going to say the rules, we're going to call fake names and email. And we're going to say the field labels, if the field label is a person name or an email address, we're going to fake it. So instead of hashing it or dropping it from the database, we're going to fake it. The next one we're going to do is a date shift. So what we're going to do is to try to make sure that people can't figure out what is what exact date someone ordered that stuff. We're going to do a date shift on it within this range. This is the format. And then we're going to do numeric shifts on the latitude and longitude. That was a hard word to say. In an attempt to make sure that we protect people's privacy so people don't know where it's being shipped to, because most people ship to their home address and we don't want to expose that data. So now what we're going to do is we're just going to create transform data. So we're going to use the Gretl client and the Gretl project. Relatively familiar if you've watched any of my previous talks. This is a library that we use a lot. We're going to go ahead and create the project. We're going to do some transform tables and the errors, and we're going to just TM comes from transform models, the multi-table. and then we're going to run it. This one takes a little bit less time than the synthesizing of the actual of the model itself for creating the synthetic data. So this one we're actually going to run. The other one we're going to depend on our previous runs to demonstrate it. So if we go back to our Gradle dashboard and we refresh the page, we should see the RDB transform, and we're seeing the, what's happening with these transforms. And I think we can view a little bit more. Creating transform model. We can view the entire config that we have. So the config that we took, that we uploaded with our rules for how are we going to transform it, we can view all of that. So here's our numeric shifts that we talked about. Here's the date shift. This is the order items one. The users one was the one that also had like the names in it and stuff. So these are, okay, the users transform is already completed. So we already have the logs. We can look at the activity, running transforms on provided. Okay. And kind of see a report of what's going on here. 2 entities detected, person name, location. Yeah. So we go back here. We're still waiting on this. I guess now is a good time to go ahead and answer a couple of questions that I had come in via the registration form. So we're going to talk a little bit about, so one of the questions was, will I be doing any sessions on NoSQL databases, or will there be sessions on NoSQL? So I'm not going to cover NoSQL today. It would be really interesting to cover a NoSQL database. So if that's the kind of thing that you're interested in, definitely drop a comment on this video. Let us know that you would like to see some content around synthesizing NoSQL databases. And yeah, maybe we can get a developer advocate from like MongoDB or something to come join me, and we can do that. And that would be pretty fun. And then another question that we had was, do you have a framework for evaluating the performance of the classification model before using it to identify PII? And my current response to that is, I do not think we have any way for you to do that, for evaluating the performance of the classification model before using it. So I don't think you can evaluate our classify models. I don't think you can use our classify models for it right now. Our model, I think you just use it, but it's a good question. I'm gonna take that back to product and ask and see if anybody has any answers to that for sure. So we're still waiting on the models to train, but it looks like they're completing relatively quickly, which is good. Okay, so they're done. It only took about 3 minutes to train that model. Yeah, the transforms are really, really quick. It's really awesome. So now we can view this transformed content. And as you can see, it looks nearly identical. One of the really interesting things that it does is, for some reason, nuns turn into nans. I think that has something to do with the way pandas displays this. I don't think that's actually the way that it works from the data, like directly from the CSV, but pandas has always kind of done some weird stuff with that. But as you can see, this data looks very similar to the data that we had earlier. So now it has been transformed. So what we have done so far is we've transformed our data so that original data set now no longer has any PII. So now if you wanted to share this, maybe say internally, you could share this. Okay, so you could, share it with team members and such like that. Internally, probably wouldn't share it externally yet. And you wouldn't have to worry too much about PII being leaked or anything of that nature. Now, this is not the strongest way. Like this is, part one. If you want to make this, you want to ensure the data privacy, further along, or you want to be able to be insured, you want to be able to know that like it's as secure as it can be, then you would definitely need to synthesize after this. So basically what we'd do next is we would save this to ecom, it's called ecom xf. We're basically going to transform it back into a database or save it into a CSV file. So what's happening here is we are basically creating a new database with the transformed records in them. Yeah. And it's the same amount of records as it was. So we still have the same amount of records. They've just been completely transformed. So what we're going to do now is we're going to go, let's see if there's anything cool here in transform. Anything more to talk about transform? No, I think we're good. So what we're going to do now is we're going to go over to the synthetics part of the side. So now that we have this database, now we can synthesize it. Now these notebooks are set up in a way where you don't need, like, I don't need to run this line of code. Like this ecom xf database already exists in our S3 bucket just for ease of use for these for demoability of these notebooks. Now, if you were doing this on your own, you would definitely want to take these, and you would have to save that database and then ingest that database in here, either by uploading it to a Google Drive or to an S3 bucket, or if you're reading it back to another database, maybe creating another database inside of Postgres or something like that. So now what we're going to do is we're going to take this transformed database and we're going to create some synthetic data off of it. So it's very similar. The notebooks are almost identical, not going to lie. They're very similar. I'm going to make sure I have what I'm looking for here. Yes, we do. Okay, we're good. We have all the data that we need. So I'm not going to run these, okay, this time, because unfortunately, these models can take a very long time to train. And as I was training these yesterday, it was taking anywhere from 30, 45 minutes to an hour to train those. And we don't have enough time today on stream. Plus, I don't think anyone wants to sit here and watch me just like stare at me while we wait on a model to train. I'm going to have to modify that XKCD on it's compiling to the models training. If you know what I'm talking about, you know what I'm talking about. It's the XKCD compiling. Big thanks to Randall Monroe for being the greatest voice of programmer humor there is. So yeah, I feel like I could change my codes compiling to my models training, and this would be perfectly relevant. This is the joke I'm going to make for the rest of my time working in this space. So I'm looking forward to it. So let's take the synthetic data. So as you see, it's the same library. We're going to log into the API the same way as we would. We're going to now take this ecom xf database. So it's the same database, okay? But now it's been anonymized by using a transform. So same database, the data should be, relatively fine. Like all of the relations are still there. Only thing that we've done is we've kind of, anonymized it to where names aren't there. We've anonymized the location data, name data, stuff like that. Identifying information, PII. From there, we basically just do the same create engine and we crawl the engine again, which is really awesome. Again, we can also do the same thing where we set up the same exact RDB config, depending on if you want to allow the crawl database to do it, or if you want to set up CSV files and do it yourself. That is totally up to you. And then this is the other part. This is a part of the code that isn't in the transform one. So this is where we set the RDB config to the synth record size ratio. So how much do we want to create? Synthesizing of 1 basically means the ratio would be a 1-to-1 ratio. We would synthesize the same amount of data that we have. A 2 means 2-to-1, 0.5 means half the data. So we're going to set it to 2. We're going to create twice as many records as we already had. So when we come here, again, we're doing this join where we're just looking at the data, and it's the same data that was from the last one. So nothing super special here. Nothing's changed. It's just a little bit more private now. And then we can set up our training configs. The default synthetic data config is here. Just downloading it directly from our config templates. We have a whole bunch of config templates, and this looks like it's in Gradle blueprints. So let's look at that config template. github.com/Gradle AI/Gradle blueprints main config templates Gradle synthetics. And of course, that was too much. Config templates Gradle. Oh, because it's tree whenever you're not doing it from raw. Okay, and then this is the synthetics, and this is the default config. So the default config here is basically all of our hyper tuning parameters. So we're gonna do it for 100 epics. We're gonna have a batch size of 64. A vocab size was like 20,000, if I can read that right. Dropout rate, early stopping, um, and all of that stuff. Validators, how many records to generate? So we're gonna generate 5,000 records. I think this won't. This will get overridden by it. And then privacy filters. So this is good. So what we're going to do here is, yeah, that the records get overridden because of it in the RDB config. So the RDB config can overwrite some of this as well, which is what we're going to see here. So we're going to copy all of this table data to the config for all of our different tables. So basically, this config is there for every single table that we have. Because what's happening is we're not like taking a whole database and then synthesizing the. I mean, it is kind of synthesizing the whole database, but you have to think of it as that, like, since this is a relational database, where basically the database has been downloaded as to multiple CSV files. The CSV files are uploaded and then synthesized and then put back together, and then we synthesize the relationships between them. So that's why our config looks the way that it does, because we have all of these CSVs of all of the user transform data. User data is in here, and all of the order items are in this CSV file, and then we synthesize from there. So by setting this, we're saying synthesize to, excuse me, a 2-to-1 ratio, and then we're going to print the number of records, which we've done. And now what we're also going to do is we're going to turn off our similarity for privacy filters. This is to just kind of speed things up. We're going to so what was it? We'll turn off similarity filter for the table distribution training. Okay, so we're only doing it for the distribution center. So for distribution center, as it only has 10 training records, so it's so small, it's really not going to help anything there. Yeah. So we run that, and then again, we create synthetic data. We're using the same library as we normally do. The only thing we're going to do here is, instead of it being like in this library, it was tm.transform tables. We're going to take it here. We're going to do sm.synthesize tables. So we're going to synthesize these tables. So we're taking all these tables and we're submitting them up to Gradle. They're going to be synthesized. The models are going to be trained, and then they're going to come back and give us the synthesized data. And it will also give us this really nice SQS score, which we've talked about before. So we train all these models. Again, we're not going to run this live today because this takes a very long time. These are relatively large tables. So, I mean, some of them go really quickly, but I think the users table, or no, the product table, I think, is the largest one. It's like 7.5 megabytes, and it takes a bit to train that model. And that is one of the things that you have to remember whenever you're doing synthetic data, and when you're training synthetic data models, is that this is still training machine learning models, and that still takes a relatively, I'm not gonna say it takes a long amount of time. What in your definition is long? But it's a non-trivial. Like, this isn't like normal running of code where things happen instantaneously. This will take a little bit. So we train the model, and then we come back and we run and basically look at the synthetic data that we've generated, and we say, how many have we created? So, for distribution center, there were 10 records. There's 20 records now. It's a 2-to-1 ratio. The big one to talk about here is this events. Oh, events is way bigger than. So maybe events is a really large one. Events is way bigger than products. So there was originally almost 50,000. Now we're almost up to 100,000 synthetic data records, and we could change that synthetic data ratio to whatever we wanted it to be, and we could synthesize more if we wanted to. And then we do the join again, and we look at our data, and we have it here. And now we have some of the highest protection for synthetic data. So not only have we synthesized a data set, which offers protection, we've transformed it and then synthesized it. So you can kind of think about it as transforming is like a little bit of protection, and then synthesizing is a little bit more protection. Independently, they're pretty good. Put them together, it's much better. So we can do that. And then we can view the synthetic data performance report on every table. So as you saw, we got a synthetic data quality score for every table that we synthesized, which is pretty cool. We can go through and say, hey, the users table was a score of 87. The order items was a score of 88. All of them were excellent, which is great. That means whenever you get an excellent score, that means that this data, there's enough confidence. That was the word I was looking for. That you have confidence that the data is private. That took forever. You with a score of like with anything of a score of excellent, you can be confident that you could use this in like machine learning model training and stuff, and it would work really, really well for you. So we basically verify it, then we view the synthetic data, and then we, as you see here, we have the 87, and then if you've never seen one of our synthetic data quality scores before, they're amazing. It's one of my favorite things. Not only does it tell you like, look, you have this, but you have these little click downs. I think these little click downs right here really what make the SQS score, because it explains everything about our methodology. So you don't just go, oh, I got an 87, and you have no idea what an 87 means. No, you click on it, it tells you exactly how you do it. It tells you how to improve it if it wasn't as high as you want. Right here, it tells you, these are the kind of tasks that you can use. You got an excellent, so this is probably great for demo or environments, for mock environments, machine learning analysis. What happens if I only get a moderate? Well, it's probably not the greatest for machine learning, but it's probably good enough for demo or mock environments. So it tells you exactly what you can use this data for. The same thing, you can talk about the way that we decide that we want to measure synthetic data quality score. So field correlation stability, deep structure stability, field distribution stability. We tell you how those work, give you some just everything about it. I like these little clicky buttons. They make me so happy. And then the training data correlations. I think this is the field distribution stability, field correlation stability. Yes, correlation. Field distribution stability, principal component analysis, and field distribution. I'm still learning those, what those are. So sometimes I trip over those. But yeah, so the synthetic data quality report, you can come and you could do on any of the tables that you wanted. Yeah, it's fantastic. Now, the other really cool thing that we can talk about now is we have these models trained, but maybe you made a mistake. Like, oh, I want more user data. Which I'm always wondering why it does that. I want to figure out why. I can't figure out which one this is. Oh, I also can't look at the synthetic data quality score because this is a different one. But say you want more data from this. Interesting. You can generate more. So come here. We can click generate 5,000 more records. And now it's going to create a new artifact for us. And we'll be able to view it. And that's pretty awesome. See if there's any other cool things I want to show you while I'm here. If anyone here is in the chat has any questions, please feel free to drop them. Happy to answer while we're waiting on that. Oh, I know I lost it. Yeah. That is generating synthetic data and transforming synthetic data. I'm trying to think of what else we can do with this. I think that's it. I think we're going to be good for today. Got through a little bit early, but that's fine. Don't always have to go to an hour. So if you have, I'm going to post this blog post in the chat again. Those of you that are here now. So this blog post is basically what I worked through this entire time. So this is a great blog post, has all of the exact same notebooks. All you need to do is sign up for a Gretel account, and then you can train and play with this all you want. So you would play with the transform, play with synthetics, mess around with them, maybe use your own data, see how it works with your own data. There's a lot of really good explanation here around it. You can join our synthetic data community, which is pretty awesome, over here on Discord. And yeah, that's all I have for today. The last thing I do want to talk about is, where's that banner? So if you showed up today, or if you watch this on YouTube and you want some free swag, you can get some swag. So if you go to grtl.ai/workshop-rdb, it'll take you to this Google form. If you give us your email address, we'll send you a package of some Gretel stickers. It's going to have this and a couple of other stickers in it as well, but this is the funny one that I like. And let us know your email, your name, And if you want to hear more about Gretel and synthetic data, you have until a week after this event, which is 9/21 at noon, to fill this out. So even if you watch this after the live premiere on YouTube or wherever, on LinkedIn or on Twitter, you can watch it there. And from there, get yourself some synthetic data swag. It's going to be really awesome. If you've watched some of our past workshops and live streams and stuff like that, and you've filled this out already, feel free to fill it out again. We'll send you probably one, but I know that we've been doing this for a little while. We're like this close. Like, we're going to get all this swag stuff like shipped out really, really soon. So if you're waiting on swag, don't worry, it's still coming. Thank you so much for attending this workshop today. We will be having another we'll be having not a workshop, we're having a deep dive on the 28th of September at the same time. So 3:30 Eastern, which is, I don't remember what that is Pacific, like 12:30 Pacific. Yeah, 12:30 Pacific. So come back next week, or not next week, on September 28th, and we will be doing a deep dive on, I believe, like multi-model approaches to generating synthetic data, which is actually a really cool topic. And we're going to have some of our research scientists here to explain that to you, and it's going to be really cool. I love doing those because I get to sit around and listen to smart people talk, and it's one of my favorite activities, is learning by just listening to people talk about the cool things that they do. So one last time, if you want some swag, go ahead and get some swag. I don't see any comments or any chats. So thank you so much for your time. I hope you enjoyed this presentation, and I look forward to seeing you in 2 weeks for our next deep dive. I'll see you around. Thank you very much.